You look at the fact that it's basically 1960s technology. It's achieving all those wondrous Stovall flight sort of maneuvers without the aid of a lot of computers.
The Harrier's ability to take off, hover, and land vertically is achieved by vectored thrust. The powerful force of its jet engine is directed downwards through 4 nozzles that can pivot 90 degrees.
I was brought in because I am a Harrier pilot with almost 1,600 hours in that airplane. So all of the lessons learned I have from the Harrier airframe and operational experience I have, I was able to bring to the program and use those to help evaluate the X-35 Stovall version.
For hovering, engineers gambled on a radical new system. They planned to supplement the vectored thrust method by harnessing the jet engine to a drive shaft that would power a fan to blast air downward.
In 1991, we unveiled this shaft-driven lift fan system to the technical world. Some actually said, "You gotta be kidding me. Are you guys serious?"
The lift fan required doors to open behind the pilot on the top and bottom of the plane to draw in more air. The fan would blast air down midship, while the jet nozzle in back swiveled, blowing its powerful exhaust down to create a balanced lift force.
The shaft-driven lift fan system allows you to harness a lot more energy out of what the engine is producing.
But harnessing a jet engine to a drive shaft proved to be extremely difficult.
The mechanical energy we were dealing with in the shaft-driven lift fan system was very large. We had 28,000 horsepower being transmitted from the drive shaft from the main engine to the lift fan. And that's similar to the power going through a U.S. naval destroyer.
The lift fan's ability to blend large amounts of cool air with the hot jet exhaust provided another important benefit.
One of the things we learned in JSF was to combine the jet exhaust to get a lower combined temperature than the Harrier. This allowed us to avoid some of the problems with concrete where the concrete would actually burst and explode under the high temperature and high jet exhaust from the Harrier.
At the Lockheed Martin test facility in Palmdale, California, the revolutionary lift fan system was put to the ultimate test, in the air. If the lift fan failed during hover, the plane would crash.
It made its first flight in 2001, and it was a complete success. And at that time, I didn't hear any more from the people who had been saying for years, this thing will never work. It worked.
Now, all 3 versions of the F-35 for the Air Force, Navy, and Marines are being developed and further tested for mass production. The United States, Britain, and their allies are expected to order more than 4,000 Joint Strike Fighters, which will replace most American-built fighter bombers in use today.
The handling qualities and performance are stunning. It really is a pilot's airplane. It sort of makes you feel like a little boy. You want to take it home and tuck it under the pillow with you at night. It's just a pilot's airplane.
In future air conflicts, the F-22s will be used to establish air dominance. Then waves of stealthy F-35 Joint Strike Fighters will use their superior weapons-carrying abilities to attack other major ground targets.
The Joint Strike Fighter is going to be the backbone airplane for hauling freight. It is going to be the muscle part of sustained forces.
Commanders can also alter an F-35's mission in the air as situations change during the battle.
There are a variety of ways for the F-35 to bring in information from external platforms, other airplanes flying around the battlefield, satellite-based assets, ground-based assets. All that information can be presented to the pilot in the cockpit and allow him to be more of a tactician and manage the tactics of the game that day instead of worrying about the nuances of flying the airplane.
The pilot's job will be to supervise the process of identifying the target and then to give consent for weapons release.
The Joint Strike Fighter will be able to carry a wide range of weapons, to include the heavier weapons such as the 2,000-pound bunker busters and 2,000-pound blast weapons.
The Joint Strike Fighter's 1-ton bunker busters and blast bombs will be guided to their targets with pinpoint precision by JDAM tail kits. The Joint Direct Attack Munition, or JDAM, is a kit that can be put on any bomb to give it the brains to know where to go, and the movable tail fins to guide it there.
JDAM is a guidance kit that came after Desert Storm. This little round piece on the side there is an inertial navigation clock. Now this clock, instead of measuring seconds, measures feet. If you take the unit and you tell it where it is right now electronically, and then you move it back a foot or you move it up a foot, it measures every centimeter and every distance.
The bomb knows the coordinates of where the airplane is, and it also knows the coordinates of where the target is. And when the weapon is released from the airplane, it simply flies from one set of coordinates to the other and does its thing when it gets there.
Because a JDAM is directed by GPS, or global positioning satellites, it can hit targets regardless of visibility.
The way we use it is by employing it against targets that we cannot normally see visually, whether it is due to weather, smoke, haze, or just some sort of other thing that's obscuring the target.
As a JDAM falls, its inertial clock keeps track of its position and signals the tail to make course corrections, directing it to the target. The accuracy of new weapons like JDAMs will reduce collateral damage. It also makes the F-35 an even more formidable weapon system.
The new weapons such as JDAM really reduce the need for the number of sorties, and that reduces our risk because we're not exposed to enemy threats as often.
The F-35's combination of advanced weapons, avionics, and stealth will help it ensure its success over the battlefields of the future. U.S. military planners wondered if these same features could be utilized in a helicopter. They wanted a stealth helicopter. But could it be done? Over the last 50 years, helicopters have evolved from slow-moving multi-purpose support vehicles to fast-moving frontline attack ships. But in the high-tech wars of the future, speed alone is not enough. Information is the key.
There's three elements that are critical to warfare. The ability for you to know more than the enemy, the ability to maneuver quickly around an enemy and gather more information about them, and the ability to provide precision firepower at the enemy.
In future conflicts, after the F-22 Raptors and the F-35 Joint Strike Fighters have cleared the way, surveillance and attack helicopters will support ground troops as they move in to secure the area.
We like to be down low where the action is, and we like to be down low where the threat can't see us.
But at such low altitudes, helicopters are vulnerable to a wide assortment of ground-to-air weapons.
All the simple systems, the guns, unguided rockets, the surface-to-air missiles, it's got to deal with all of that, and it's got to deal all of it effectively.
The Pentagon has responded with a two-pronged strategy to counter this threat: inexpensive, expendable unmanned helicopters and stealthy